All right, everybody, let's take a look at the CFU for 3.6 here. So number one here, and it's actually the only one we're doing here, is referring back to your CFU problem from 3.2 number one. So just to kind of put us back in the context, gives us a data from a study that shows that social inclusion causes real pain. That is activity in the area of the brain that responds to physical pain goes up as distress from social exclusion goes up. As the scatter plot shows a moderately strong linear relationship. The figure below shows a Minitab regression output from this data. So basically this problem gives us a computer output that analyzes this data from the problem back in 3.2. And we want to be able to answer some questions from it. Okay? So an A says, what is the equation of the least squared regression line for predicting brain activity from social distress score? Use the equation to predict the brain activity for a social distress score of 2.0. So we actually have a couple things here we need to do. So when I do these equations, the first thing that I like to do is make sure I know what x is and what y hat is. So x in this particular case is the social distress score. Okay. Y hat is predicting the brain activity. So brain and I might say brain activity score. Or you could say value too. So now it says use the equation. So we got to get the equation. So all that information comes from right here. So remember, notice how this distress right here is the x value. So this number is in front of the x. This value right here is my slope. So I know it's a little fuzzy, but I know my y hat equation has a slope of 0.06, I'll say 0.08, okay? And the other value is my y-intercept. So this value right here is my y-intercept. So my equation is negative 0.126 plus 0.06, let's go 3 decimal places, so I'll go 1x. So there's my equation. So now, the last part of the equation asks you to use it to predict a social distress from a social, or predict brain activity for a social distress score of 2.0. So y hat equals negative 0.126 plus 0.061 times 2. So y hat equals, so exit out my calculator here, negative 0.126 plus 0.061 times 2 gives us a value of negative 0.004. So almost 0. All right, so that takes care of A. Very important to know how to come up with that equation and use it to do a predicted score. All right, B says, what percentage of the variation in brain activity among these subjects is explained by the straight line relationship with social distance score? Ooh, again, what percent? That's r squared. So here's the cool thing, is they give you the r squared right in it. Don't ever use the adjusted one. So we could say 77.1% of the variation in brain activity among these subjects is explained by the least squared regression equation. All right, so now the question becomes, it says use the information in the figure to find the correlation R between social distress score and brain activity. How do you know whether the sign of R is positive or negative? So what I can do is I know that R squared equals 0.771. So what I need to do is take the square root of both sides to get my R value. Technically, it is plus minus. So if I do the square root of 0.771, I get an R value of plus or minus 0.878. Now, the question is it positive or negative? Okay. So R ends up being here positive. And the reason why it's positive, our R value, or our correlation coefficient, is positive since our slope was positive. They'll have the same sign. So since our slope up here, 0.061, was positive, our R value will also be positive. All right, last but certainly not least, a last question here on D says to interpret the S value. So our S value here is let's say 0.025. We'll go up 3 decimal places. So S equals 0.025. Again, S is the prediction error. So we would say our least squared regression equation has an average prediction error of 0.025 when predicting, what were we predicting? The brain activity score. When knowing the X value. That's why I like to define it, knowing the social distress score. All right, so I'm hoping that this example really helps as we prepare for the test, because I can guarantee you you're going to see something like this where you're going to have to identify some of these key pieces from a computer output. All right, hope this helped.